introduce yourself. You're now on Sensible Live TV.
Hello there. Today on Sensible, we have an update on the electromechanical part of Copenhagen project. So before I go on, a quick recap. We need to keep three design principles firmly in mind, and these are irrevocable. First is that we need the motor speed to be controlled via a torque or RPM or a user input, which is non-intrusive, which we have thought of to give via the pedaling action. The second is that we need to have internal hub gears with coaster brake, because we want the braking mechanism to be tightly integrated with not only the regen braking but also in terms of control, one common action for the user, so you don't have different brakes. So that's a big design principle. And the third one is that it needs to fit in the hub. It's compact and you cannot have little gadgets all over the place. So if any design solution we come up with, we should have these three. Okay, so that out of the way. We have two concurrent work streams which have been going on for the past couple of weeks. The first one is trying to communicate these design principles to Ducati and helping them come up with a solution which they can fabricate. So in this, the current status is that we are going to have, just after this, a meeting with Ducati to see how far they have got with the torque sensor design. They have already ordered the coaster brake, and
they've already ordered the whole. They told me they've ordered the Hall effect sensors.
Okay, cool. That's
Yeah.
great. Yeah, the
So
Hall effect sensors,
yeah.
and we'll be shipping them the Kolmogen motors on 7th October. We have already dispatched the AMC controller to them. So hopefully at their end they will first do the mechanical assembly to see where everything fits together. And once the mechanical side is solved and the torque sensor manufactured, I think that there's a good chance that they'll be able to make it in time for the Copenhagen Summit. So that's once the high priority stream which we are working on, coordination and communication with Ducati. Okay, so that's that part. The second concurrent stream which we are working on is trying to build this in-house. For that, we have been thinking of two options. The first one is using a existing hub motor with integrated coaster brake. Unfortunately, such a model is not available. The one which we thought, the giant light bike, is actually not compatible with us. It does not integrate directly into the coaster brake. It actually has a chain-driven system. So that drives our design away from the hub motor, because since there are no commercially available hub motors which are compatible with coaster brakes, we are left with the choice of having, because the coaster brake is an integral and irrevocable design principle we have to adhere to, then we are left with the choice of having a offset motor.
Or using the Kolmogen, but we'll see how that goes
case,
when the Kolmogen arrives.
Right.
So,
but again,
okay.
this is for the in-house design. So, or using the Kolmogen. But the Kolmogen option is, we don't know anything about the motor or the controller. So
yes. So until it arrives and until our controller
we
arrives.
need to keep that on hold and design with as if we are we are designing this from a blank slate with components which we understand. So keeping that in mind, an offset motor now has to satisfy certain criteria which are different from the hub motor. So first of all, it has to be much smaller in size, because the hub gear system will occupy a certain space, and we don't have the integrated hub motor outside the hub gear. So the motor which we actually choose has to be much smaller. So we have a particular configuration and design solution here with components for an offset motor design. Interestingly enough, an offset motor design was one of the first things which Millenworks had also considered. So I think it's workable. What we have here is a motor which is over here, the yellow part. This drives a gearbox, a reduction gearbox, and this is coupled via a direct gear drive system to the hub gear outer casing, the hub gear's outer casing. So this will drive this will drive this, and this will drive the hub gear. So the hub gear itself is tightly coupled to the rotating element. So as the motor drives the hub gear will rotate the wheel. You have the spokes attached to this outside the picture, but this is the rotating element, so you have the spokes. Right. So that's how this works. On the other side, you have a stationary element, which is the stationary structural casing. This actually has the axle which goes through this. Outside, a conventional freewheel which the hub gear comes with. It's integrated with the hub gear. And this freewheel gets its input from the user via the pedals and the chain. As this rotates, the hub gear also can rotate. So this is a conventional operation which can occur independently of what the motor is doing. So you have pedal assist possible. Now, the way that the control signal will get passed to the motor is via an RPM count, which is it's a optic counter of how many revolutions occur, and also, interestingly enough, the direction of revolution. So you can now calibrate the control mechanism to take the signal from here and know how fast the user is trying to go. This is a good proxy for torque. When it goes in the reverse direction, the idea is that it should activate regen braking. So just before the coaster brake kicks in, snaps, and makes mechanical braking the state, we have the RPM count signal going to the regen braking circuit, and then we have regen braking occurring just before the mechanical braking. So let's see a little bit in greater detail how this is arranged. You have, right, okay, it's fine. So you have this particular component, which is a motor. This is a brushless outrunner motor. It is one of the outrunner motors generally have a tremendous torque to weight ratio. So this has a dimension of about 6 into 7 centimeters, which is about this size. It's pretty small. This gives an RPM of about 4,400, which is obviously too much for an electric bicycle. So we need to reduce this. We have a first stage reduction gearbox which does this 6:1. So this is going to be attached, coupled to the motor itself on the shaft side. The output of this gearbox will drive a small gear over here, which then will be coupled to, like I said, with a larger gear. This is the second stage of reduction, gear reduction, to the coaster brake and internal hub gear. So maybe this might give the side view, the side profile might give a better idea of how this system is working. You have the motor, then you have the gearbox in front of the motor, and you have the gearbox, output of the gearbox, the shaft driving the smaller gear, coupled to the bigger gear, which is then coupled to the internal hub gear. So this is how you have the motor driving the hub gear, and all of these parts are off the shelf. So you have, like I mentioned, the gearbox is off the shelf. We have gears which we can use the commercially available standard sizes, or we could custom make particular gears with particular teeth from e-machine shop. So that's definitely possible. We have a coaster brake 3-speed, which we can use either a Shimano or an SRAM. Size is not an issue here because the motor is so small. We can play with sizes of the hub gear, whichever is the most reliable one, which we find which integrates the best with the mechanical casing. Then to change the internal gear from 1 to 3 or 1 to 5, depending on which model we choose,